Alright, good morning and welcome. Today I'm going to show you how to calculate or find the derivative of a function using first principles. And then the next few videos will be about the chain rule, product rule, and quotient rule. Okay, so to find getting the derivative basically is getting the gradient or the tangent at a particular point. Now in this case, from what you know, gradient is basically rise over run. So what we want to do first, all right, is get the gradient of the second, what we call the second over here, which is just this turquoise line-ish, this joining P and Q over there. Once we can get that, then what we will do is reduce this value of h, or we'll derive it with the limit as h approaches 0 to find this particular tangent at this particular point P. Alright, so what we're going to do is we're going to come up with a formula. So this formula here comes from rise over run. So we've got this function f of x, right? We've added a h to it, right? And so when we want to get the gradient, we've got to do change in y. So rise is basically change in y over change in x. And so our change in y is subtracting f of x plus h from f of x. Sorry, that's the other way around. I want to subtract f of x from f of x plus h. And the same thing I want to do in my change of x. So my x has been increased by a value of h. So if I do x plus h, so this basically comes from doing x plus h minus x. And so what would happen is these two values of x would cancel out, and what I have left is h. Okay, I hope that makes sense. So what I was saying initially was that we are getting this tangent, the gradient of this tangent here. Then what we will do is we will create a limit where h approaches 0. So the minute it gets to 0, we will then know what the gradient at P is. So we have got a formula, and that's the one that you're going to use to find calculate the derivative using first principles. So the gradient of y equals f of x at any point x is given by a function called the derived function, or the derivative. So gradient and derivative, very much the same thing. And we represent them by calling them f prime of x, or just dy by dx. Alright, so let's use first principles to differentiate. F of x is x squared minus x. We know that we've got our formula for gradient, and that's what it is from the graph that we just we derived it from the graph over here. All right, so first things first, I want to try and find f of x plus h, and that basically is wherever I have x here, over here, and here, I'm gonna replace that with x plus h, and then I need to simplify that. So I've got x plus h squared minus x plus h, and that's what I want to get first. So let's simplify that. Xh plus h squared minus x minus h. So what I have got is I've literally just got that bit. Now I can get the gradient. So the gradient is f of x plus h. That's what I've just simplified there. And then now what I'll do is I'll introduce that bit here. And so I've got minus f of x, which is just this over here. Put that in brackets. Be careful of your negatives. And that all over h. I'll simplify it further. Alright, there are a few things here we can cancel out. So we've got a positive x squared and a negative x squared. We've got a negative x and a positive x. That's it. You've then got 2xh plus h squared minus h. That's over that. If I simplified the factorize h out of the top part, you got h into 2x plus h minus 1, and that's over h. And what I'm left with really is those h's cancel out, and I've got 2x plus h minus 1. But really so what we are getting is the gradient as h approaches 0, which you should have in your equation to show that as h approaches 0, what we really are left with is 2x minus 1. That should be your final answer. So the gradient as h approaches 0 is 2x minus 1. I hope this video was helpful.